Today we're going to be talking about how to pick structural stormwater BMPs on industrial sites. I'm Ryan Janik. I'm one of the founders of Mapistry. It's been about 13, 14 years now in the environmental and stormwater space, focused heavily on treatment technologies and also software for industrial facilities, how to deal with their stormwater permits. We're really lucky to be joined today by Kurt Marx. He's Mapistry's Director of Stormwater Engineering. Previously, he co-led the state of Washington's verification, certification, testing program around emerging technologies in stormwater. He's our go-to in-house expert on all things related to stormwater treatment technologies, from simple DIY BMPs, which we're going to show you later in the webinar, to like full-scale systems, picking which vendor will work for a variety of situations, whether it's dealing with metals, TSS, turbidity, etc.
I'm going to talk about some strategies on how to or not to select treatment technologies. There's a lot of information out there. There's a lot of products. Some of them work better than others, and some of them are just more appropriate for other situations. One example of where things can get confused, I think, is this is just a state of Maryland example. The state of Maryland is located within the drainage or portions of it in the area of the Chesapeake Bay, a big, wonderful water system that has some issues, and there's a lot of efforts undergoing to help protect and improve water quality of the Chesapeake Bay area. This is their industrial permit, some language from it, and part of that language for their industrial permit is taking 20% of your untreated impervious surface and putting in stormwater treatment measures or controls for the reduction of nutrients. We want to reduce nutrients to prevent eutrophication and further degradation of the Chesapeake Bay system. So within your industrial stormwater permit, they're talking about TMDL, a regional program to help Chesapeake Bay effluent pollutant concentrations to below your permit benchmark, your permit NAL. So within here, they mention practices found in the state design manual for stormwater or other proprietary practices that they have a list of that have gone through their proposal or their certification verification program, and they put that on there. So keep in mind, those proprietary practices are designed for, meant for that 20% of your site, which is a regulatory limit to deal primarily with nutrients and to some aspect TSS. So if we go to this proprietary practices, and as Ryan mentioned, there's a lot of proprietary systems out there, or there's non-proprietary systems that you can build yourself. But so some of these, this is a list of some of these programs throughout the country, and I'm not going to go over each of these, but these are meant for municipal development and redevelopment permits, and also things like TMDLs. So they're not really meant for industrial type programs. They're primarily for the municipal stormwater permits, phase 1 and phase 2 entities, large cities and counties that permit construction projects to build or rebuild large facilities. It can get kind of confusing or a little bit muddled on what you want to select for your treatment device. The question is, and I think I just answered that, should I use these lists for selecting my industrial permit treatment device? And the answer is almost always no. How do municipal industrial permits generally differ? Industrial permit facilities, they're usually private facilities. There are some governments in there. The municipal permits are cities or county projects or approved private developments. Industrial permits also have a lot higher pollutant concentrations and a wide variety of pollutant sources, whereas municipal permits is pretty common, whether it's a high density residential or commercial site. Also, the big thing with municipal permit, when you do have treatment, there's no sampling required. It's a presumptive approach. We put the unit in the ground, we design it, size it properly, and with the assumption that it's maintained. Here's maintenance cropping up again. We assume that if you put it, install it, size it, and maintain it, that it's going to remove a certain level, say 80% of the TSS required or going through it. So whereas the industrial permit Obviously, you have to do your sampling and meet certain effluent benchmarks or NAL concentrations to meet your permit. Often, industrial permits are at places where you have staff. There's a business that's going on there, there's staff there, there's power, there's lights, they're often fenced, someone's around there. Whereas the typical devices or approaches used for municipal permits, it's a pond in the back of the property surrounded by a fence, or it's an underground proprietary device. It's great, we can put them underground, we can save space, have more parking, but they're underground, they're gravity driven. Sometimes they're just put in there and forgotten. So I'm saying, if you can't go to one of those lists, how should I pick a treatment system? Use someone who knows a treatment system, a professional engineer that has specific experience in stormwater and stormwater treatment, or other practitioner that has done specifically stormwater treatment. You might want to consider doing a pilot test before investing in a large system. Have a smaller scale system that tests a side stream, so you can make sure that that approach is going to meet your effluent concentrations. You might need to take extra samples beyond just the bare minimum of what. So I'm saying, if you can't go to one of those lists, how should I pick a treatment system? Use someone who knows a treatment system, a professional engineer that has specific experience in stormwater and stormwater treatment, or other practitioner that has done specifically stormwater treatment. You might want to consider doing a pilot test before investing in a large system. Have a smaller scale system that tests a side stream, so you can make sure that that approach is going to meet your effluent concentrations. You might need to take extra samples beyond just the bare minimum of what your permit requires. So we talked about total and dissolved metals to see if we can settle them or screen them out, or if we're gonna have to do something more like a cation exchange with a resin or a granular activated carbon to remove dissolved metals. We'd also want to consider taking a PSD, particle size distribution test. So that's not only saying, is it dissolved or particulate, but it's going to say, of those particles, what is the range in sizes? Do you have a lot of your permit requires? So we talked about total and dissolved metals to see if we can settle them or screen them out, or if we're going to have to do something more like a cation exchange with a resin or a granular activated carbon to remove dissolved metals. We'd also want to consider taking a PSD, particle size distribution test. So that's not only saying, is it dissolved or particulate, but it's going to say, of those particles, what is the range in sizes? Do you have a lot of fine particles, like 5 to 20 micrograms in size, that are going to be pretty difficult, or do you have larger particles, say 100 to 500 microns in diameter, and those could be settled with gravity? So kind of honing in on how to remove that are like your facility.
Can you give some examples of BMPs that you've seen, you've had success with dealing with, like copper or zinc on industrial sites?
Somewhat. I've been up in the Pacific Northwest and in Washington State, so we've had our industrial permit going for a while here, where we've been in a level where permittees can get into the level where they need treatment. So I mean, on the extreme end is often electrocoagulation or chemical flocculation, say with a chitosan chemical that causes things to flock together. And even if you have some of those dissolved or in between dissolved metals and particulate metals, very small, when you get the flocculants together, they'll trap or absorb some of those metals and then filter them out via sand filter. So those do work fairly well for even metals, for copper and zinc, but they are kind of the most extreme case for treatment where you need to go to. Also, anything really that's carbon-based, activated carbon, the zeolite, perlite mixes with either compost in them or an activated carbon can do that definitely, to absorb some of those types of coppers and zincs.
Yeah, and you'll often see them referred to, what Kurt was talking about for the audience, is that chitosan as a flocculant. You'll see it called a chitosan enhanced sand filter sometimes. And then the reason carbon products are so good for metals is any kind of organic carbon based is really going to grab onto those metals. And that's why the compost, the activated carbon, et cetera, can be really good when you're putting together some sort of filtration media mix for some sort of treatment system.
A lot of the biochars, there's been a lot of biochar research and products developed, so high carbon content of biochar and lots of surfaces. So I think some of those two are very good approaches.
Yeah, and the biochar product is interesting because it's significantly lower cost if you look at it on a pound per pound basis as opposed to activated carbon. It's kind of a developing market. You may have trouble finding some suppliers, but cost-wise, it can be much more cost-effective than going to an activated carbon. But it is definitely, as Kurt said, an emerging field and a lot of potential as a filtration media.